Hello everybody, I will start my today another live coding session. So in my today's video, I will solve this question, continuous Subarray sum. So in this question, I'm giving an integer array nums and an integer k, and I will return true if nums has a good subarray or false otherwise. Okay, so the inputs should be integer array nums and k, which is integer, and the output should be the boolean. Okay, a good subarray is a subarray where it ranks is at least 2, and the sum of the element of a subarray is multiple of k. Yep. Note that a subarray is a contiguous part of the array. Okay, not the subsequence. An integer x is multiple of k if there exists an integer n such that x is n times k. 0 is always a multiple of k. I see. So n should be 0, 1, 2, 3, 4. Blah, blah, blah. Okay. So let me clarify the problem. So as I said, I'm giving integer array and integer k, and I will return the boolean. So this is interface. Okay. And also I try to check some constraints. So yep, I'm wondering if this nums length of the nums is at least 2 or maybe 0 or 1. Because 0 or 1, I cannot take any good subarray. I should just return false, I think, but I just want to confirm. And I can find that length of the num is 1 or larger. Okay. And also I'd like to check each num is integer or I'm sorry, it's integer, but could it be 0 or negative, or is it only positive? I will check it, and I find that where is it? Each number is 0 or larger. Okay. Good. Aside from that, yep. Also, I want to confirm this k. This k should be 1 or larger. Good. Okay. I don't have to think of the 0 or negative number for k. Good. I think I confirmed the constraint I'm taking care of. So let me start with seeing some examples. So let's say k is 6, and I'm given k, let me say 3. Yeah, let's think of this case. So in this case, what I'm looking for is an array whose num is at least 2. So at least this one. Yeah. And if I start from here, I take a look at 2 numbers, and this is not multiple of 3. I keep up, expanding it, and now I find that 1 plus 2 is 3, and 1 plus 2 plus 0 is also 3. So this is also the good subarray. This one too, yes. So next I will start with this position. If I start from this, yep, I can find only this one, 0. Yeah. And let's say I start from here, and I can't find any. So next I try to start from here, and I find 0 only is multiple of k, or 0, 3, 2, in that way. So I keep doing it. Yeah. And because I've already found a good subarray, I will return true. Okay, good. So I think I've already come up with the brute force approach. I mean, start from each index and try to expand it until the tail. And if I find a good subarray, I can return it. So it should be O of n squared time complexity, assuming that there are n element. I can start from each index. There are n start, and for each, in the worst case, there are n numbers I have to scan until the end. Yeah. So I think this is a kind of brute force approach. But I think I can optimize this. So if I'm thinking of the K3, I just have to think of the modulo, I think. So let's think with the case when K3, then I have more larger number. Because I'm taking care of the, if the total sum is the multiple of K or not, the modulo is enough. If I change this to modulo, it doesn't lose any information. Yeah. Then what I can do, wait, maybe I don't have to, but let me forget it for now. Maybe this is not enough. Maybe I will come back and do that, but I think I don't need it. Yeah. So basically my idea is, when I think of this range, this total sum is this minus this. Okay, so when I think of the modulo, I can say it can be like this. So what I mean to say is, if I use the prefix sum, yep, I should say prefix sum modulo. Yeah. So if I find this that currently y divided by 3 is, say, 2, and z divided by 3 is 2, then I can say x divided by 3 is 0. So what I mean to say is, if I can find prefix modulo, so if I can find this means that, yep, I find good subarray. So again, yeah, the reason why I take the modulo of this prefix sum is because if I keep, say, 11 or 12 or, yeah, so let me just write it here. So So this should be first 3, 11, 11 plus 0. This is the prefix sum. And the modulo should be divided by 3, so it should be all of them are true actually, so far. Yeah. The reason why I take modulo is now number prefix sums in this list is now only k element at max. Yeah. And also, if I try to find this, let's think I will make this the set. Then, if I'm looking for 2, modulo 2, if I take only the prefix sum, I have to scan each of them to find element whose modulo is 2. But if I keep modulo, I can use the set inclusion, which only takes a constant time. So it speed up. So this is my basic idea. Again, I will say, I will keep the prefix and modulo as a set while traversing the, array. And, for every index, I will try to find if there is a good subarray whose end index is that index. Yeah. And to find it, I will think, what's the current prefix and modulo until current index, which is y. Then modulo of y. And then inside of the set, prefix and modulo set, I will try to find the same modulo as y based on k. I'm talking about z. So I'm checking if there is an array z, subarray z, whose modulo is equal to y. And if there is, I can say I found it. So x is now modulo 0 based on k. So I could find the good subarray. I can return true. Yep. Okay, and if I can't find it, I will return false. So that's a basic idea. But still, I have to take care of one more thing, which is good array has to have at least 2 elements. Sorry, at least 2 ranks. Yeah. So let's say this should be the hash map of modulo to last index. So in this way, I will check one more thing here. Last index is, because let's say if the current index is here, I have to have at least 2 ranks. So the previous index whose prefix and modulo is equal to the current, prefix and modulo must be here or later. So I have to check this. Yep. So if both of them are true, this means that I could find the prefix and modulo. Sorry. Yeah, prefix. Good subarray. So it will return true. Okay. So with this approach, time complexity is O of n because I will do traverse the end index of each index in the given array. And for each, it takes only the constant time. So what I'm doing in line 52 to 54 is I'm checking in the set, which takes only the constant time. And also I'm checking line 53, last index condition, which takes only the constant time. And I return true, which takes a constant time. Oh, and here, I have to do this. So this takes only the constant time as long as I keep track of the prefix sum solver. Yeah. So this takes only the constant time. So it should be O of n. For space complexity, n is a hash map, which is prefix and modulo to last index. And this has up to k elements, every pairs, because E is the modulo of k, so they could be up to k. So it should be O of k. Yep. So that being said, I will start the implementation. This is quite lengthy, but I think this is the best name for readability, so I will go with this. So, and one more thing I have to take care is if I mean I have to start with 0, -1. Yeah. So I will think that I will assume that the sum until here is 0. And index should be -1 here. So this is important because when I think of this and this, like first two elements, or I mean any subarray which start from the first element in the given array, I have to, I mean, if the modulo of the array is 0, obviously it is good subarray. So I mean, adding this 0 to -1 into this hash map, I can find it. I can notice that when I think of this, say, first three elements. Yeah. And also this works well with -1 because at least the I'm checking at index 1, and if I find it, it should be valid because -1 minus -1 is 2. Yep. Sorry, 1 minus 2 is -1, which is equal to -1. But if I find only here, only index 0, it doesn't meet the condition line 54 because it has only one element. So this initial condition works completely fine. Okay. And for each, okay. Here I will do prefix and solver plus equal num I, and I will try to find if there is a good subarray here. So let me rename this to current prefix. Yeah, I think I just have to keep track of this. I mean, in this way. So I can confirm here, and I will check this. If this is true, which means that I could find the, good subarray. I think I can like this. This looks so long rhyme, but it's just because, the variable name is so long. So I think I can do it. Yep. Okay. And otherwise, here in line 56, I register current prefix and modulo to prefix and modulo to Rust index. Yep. But I have to take care if this key exists or not. If it doesn't, I will create. Yep. Okay. Wait. No, I don't have to create it. This can just work. If key doesn't exist, it creates a new key. If not, if key doesn't exist, update it with I. If key doesn't exist, new key is created, obviously. Okay. And I will return false in the end. Good. Let me quickly check. I initiate the prefix and modulo to Rust index with the 0, -1. And in line 71, I initiated current prefix and modulo with is equal to 0. Yep. So in line 74, for each index, firstly, I update current prefix and modulo. Then, if that modulo exists in the hash map and the last thing index is I-2 or before, which means that I've found a good subarray, so I will return true. Otherwise, I register the current prefix and modulo to the hash map and keep going. Okay. Let me quickly check my code. So I will go with very simple case. Like this. And I will see which lines are not covered. Then I will think of another test case which covers the line I couldn't cover. Okay. So prefix and modulo to Rust index is initiated with 0 to -1. And in current prefix and modulo is initiated with 0. Okay. And actually this covers the case that the, the good subarray begins from index 0. So I can test that in line 79, 0, -1 initial value works and helps. Okay. So in line 83, I should be start from 0 to 1. And I take a look at index 0 case first. So current prefix modulo is 0, and num size is 1, So this becomes 0 plus I. So 0 plus 1 divided by 3. So modulo is now 1. Okay, so current prefix modulo is now 1. And then line 86, 1 is not in this hash map. I go to line 90 and I append this to prefix sum modulo to Rust index. So 1 should be 0. Okay. Good. And I come back to line 83 and now I is 1. And current prefix sum modulo plus nums I is 1 plus 2 is 3 divided by 3. So modulo should be 0. Okay. And then line 86, 0 is in the hash map, yes. And that value should be negative 1. And I is now 1. So this is met. Negative 1 is smaller than or equal to 1 minus 2. Okay, so I return true. Good. So I passed this test example. And also I could check that this initial value, 0, negative 1, worked and helped. Good. The only case I couldn't cover is line 92, where I should return false. Let me quickly check with very simple example again, like this. In this case, I initiate the hash map with the same value, current prefix sum modulo begin with 0. And in line 89, I should be only 0. When I is 0, current prefix sum modulo is updated to 1. And then in line 92, current prefix sum modulo 1 is not in the hash map. So I go to line 96 and I append 1 to 1. Wait a minute. So 1 to 0 because now I is 0. Yeah, it's appended to the hash map. And then I finish the iteration, so I return false. Okay, good. I covered this line 98. Maybe it looked a bit naive, but I could cover it. So overall, I'm pretty confident in my code because I could cover all the lines. So I submit. Oh. Syntax error expected. Let me see. Good. Wrong answer. Oh. So let me take a look. So let me print out how it is going. So in this case, all the prefix sums should be 0, 2, aside from the first one, 0. So 2 to 0, 2 to 1, 2 to 2. This is okay. Yeah. And the problem is, I think when I is 3, I can find the good index array, so good sub array. I mean, at this moment, current prefix sum modulo should be 2, and the sub array also I is 3, and the prefix subarray should be... I see. Okay. The mistake I made is, so, here, last index is pointing to here, but obviously, this has ranks 1. That last index just indicates that at least, the smallest subarray is at only 1 ranks. And I'm taking care of the longest subarray, which ends with this, because I would like to know if it exceeds ranks 2. So instead of keeping tracking of the last index, I have to keep track of the first index. Then, in this case, here, now 2 should be the first index 0. And I can say, in the, longest subarray whose sum is modulo is 3, which ends with this, is this one, 3. And it longer than 2 or equal to 2, so I should return true. That logic can be said. Okay. So now I update last index to first index. And in line 106, instead of taking I will take many of them. So no, if this doesn't exist yet, I set it. Otherwise, I don't set it because I want the first one, always. Okay. Now let me try with this. Sorry, if not in this, I set it. Okay, I submit. Good, accepted. Okay, so I will quickly wrap up. So today I solved the question, continuous subarray sum. And in this question, I'm giving an integer array nums and integer k, and I will check, my task is to check if there is a good subarray. The good subarray is at least rank 2, and the sum of the element is multiple of given k. So in this question, as the optimized approach, I used a kind of prefix sum modulo hash map. So prefix sum modulo to first index hash map. So this is it. And I iterate, traverse the given nums, and each index, I will think if there is a good subarray which ends with the current index. And to answer that question, I keep track of the prefix sum modulo to first index hash map. Yeah. So if there is an element, index which has the same modulo as the current end, first element is the current end subarray sum, and if that subarray ends before or equal to I minus 2, then I can say there is a good subarray. So I will return true. Otherwise, I keep going. And two things I had to take care of that. Number one, I have to initiate the hash map with index 0, modulo 0 to index -1. Yeah. And the other I mean, number two, I had to take care. I have to keep track of the first index as the value of the hash map, not the last index. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.